Number 3, we're finding the limit as x approaches infinity of this rational function. If you want to use L'Hopital's rule on this, again, that's fine, because the semester test is multiple choice. It won't really matter how you solve the problems as long as you can get the correct answer. So if you want to use L'Hopital's rule, skip ahead in this video and I'll work it that way as well. But I also want to work it the way that we learned when we first started learning about limits, which is to divide everything by the x term with the highest exponent in the denominator. So in the denominator, the x with the highest exponent is x cubed. So we're going to divide everything in this fraction by x cubed. We have x cubed over x cubed minus 2x squared over x cubed plus 3x over x cubed minus 4 over x cubed. That's the numerator. Everything in the denominator also gets divided by x cubed. By the way, we're doing this because if we were to go ahead and substitute in infinity here, we would get infinity over infinity, which is an indeterminate form. And it's one of the indeterminate forms that you can use L'Hopital's rule on. Okay, if we continue here, x cubed over x cubed is just 1. So we're just going to simplify everything that we can. The x squared and 2 of the x's in the denominator cancel here, which leaves us with 2 over x. The x and 1 of the x's in the denominator here cancel out and leave us with 3 over x squared. And then still minus 4 over x cubed. In the denominator, we're left with 4 minus 3 over x plus 2 over x squared minus 1 over x cubed. Now when we go to plug in infinity, we have this 1, that doesn't change. Minus 2 over infinity, which any number divided by infinity is 0, plus 3 divided by infinity squared, which will also be 0, minus 4 over infinity cubed, which will also be 0. In the denominator, we have 4 minus 3 over infinity, which is 0, plus 2 over infinity, which is 0, minus 1 over infinity, which is 0. So that leaves us with 1/4 as our answer. Now, if you were to work this same problem using L'Hopital's rule, so we'll say, I'll do a little LH here. We still have the limit as x approaches infinity, and then we're taking the derivative of the numerator. So 3x squared minus 4x plus 3 over the derivative of the denominator, 12x squared minus 6x plus 2. Now, if we were to plug in infinity now, we would still get infinity over infinity. So we need to use L'Hopital's rule again. Derivative of the numerator is 6x minus 4. Derivative of the denominator is 24x minus 6. Plug in infinity, you still get infinity over infinity. So let's use L'Hopital's rule again. Derivative of the numerator is 6. Derivative of the denominator is 24. 6 over 24 is 1/4.